In this lecture, we're going to talk both about some optimization with respect to containers and networks, and how containers replicate the functions of the cloud provider. So we'll start by talking about pods. So let's suppose you want to send a message from one container to another. If you put the message on the network, then it's going to take longer than if it were just done in memory. So if two containers are on the same host, you can send a message from one to another without using the network. And a pod is a construct from Kubernetes that ensures that two containers are deployed upon the same host. So you put two containers in the same pod, and they are deployed together. And then pods are divided into namespaces for isolation purposes. So if you look at the architecture, we have a pod with several containers. We have another pod with only one container. We have another pod with several containers, and so on. Those are divided into namespaces, which lives on top of Kubernetes, which lives on top of the container runtime, which lives on top of a node. So if you have a single container in a pod, pod's got an IP address and a collection of ports, and a message is sent to the IP and a port, and the message is passed to the container in the pod through the pod mechanism. If you have multiple containers in the pod is the one with the IP address. The containers don't really get IP addresses when you're using pods. And the pod also has a collection of ports. So each container listens on one port, and it's distinct from the port of the other containers in the pod. A message from outside the pod is delivered to the pod, and then it's because the pod has the IP address, and then the port inside that message is delivered to the container that listens on that port. A message from one container inside the pod to another container inside the pod can be sent locally, and that avoids the network overhead. And then it's delivered to the container listening on the destination port in that pod. Containers in the same pod are allocated and deallocated together. They have the same lifetime. And two containers should be placed in the same month. So this is a design consideration. When do you place two containers in the same pod? It's when they are tightly coupled. They communicate frequently and their actions are interdependent. And then another term in Kubernetes is a Kubernetes cluster. And so that has one master node and a number of worker nodes. And that can be either on a physical or a virtual machine. You recall the architecture picture was sitting on a node. And so a node is either a bare metal physical machine or virtual machine. And the master node contains or controls the state of the cluster and is where task assignments are made. Worker nodes manage the components that run on the application. So we have nodes, and they're divided. We have a cluster is defined as a master node with multiple worker nodes. And then inside the worker nodes, you have that architecture that I was talking about that we talked about in a previous slide. So the Kubernetes components, the cluster components, you have a scheduler that assigns containers based on their resource requirements. And when pods have no assigned nodes when they're empty, it selects one. So the scheduler selects one for them to selects a pod for the container to run on. You have the API server, and that exposes a REST interface to Kubernetes resources. And it's the front end of a Kubernetes control plane, and I'll talk about control plane in a minute. And then there's something called a kubelet that assumes that keeps track of containers and makes sure they're operational. So it's a health thing. There also is a proxy, and that maintains all the network rules across the nodes and manages the network connectivity across every node in the cluster. And there is the controller manager, and that executes controller processes and ensures consistency between the desired state and the actual state. It manages all the node controllers, the replication controllers, and the endpoint controllers. And then there's etcd, which is a distributed coordination system. When we talked about distributed coordination systems, we talked about Zookeeper. etcd is a different one. So map this into the kinds of things that get done on a virtual machine. So or in the cloud. So in the cloud, there's a health checker. There are auto scaling rules. Uh, there are gateways to control access. There are firewalls. And this is a replication of some of those functions. And how do you specify something for Kubernetes? Well, first of all, you do it in YAML. Um, then you give the pod a name. You say what containers are included in the pod, how many instances of the pod do you want to create, and what are the auto scaling rules for the containers. So a couple of questions for offline discussions. What are two containers that should be in the same pod? And now suppose one container in a pod fails. What happens to the other containers in that pod? Again, questions for discussion. And so now let's talk about orchestration and service mesh. So again, the cloud manages virtual machines by scaling, by health checking, by monitoring, by load balancing, and so on. And collectively, these are referred to as orchestration functions. So the word orchestration is used a fair amount in software engineering. And this is orchestration. We're going to talk about orchestration of containers. And so orchestration functions are not only provided by the cloud for its virtual machines, they're also provided for containers. And they're performed through a service mesh. And that's an infrastructure layer, and it has built-in capabilities to handle communication, resiliency. Resiliency means what happens if it fails, service discovery, and load balancers. Again, replicating the functions in the cloud. And so if you look at a service mesh, then what you have are containers, and they're headed by proxies. So all of the things have a proxy. So what does the proxy do? The proxy is a container, and it acts as a sidecar. It's associated with each instance of a microservice. And they know about the service mesh that they belong to. And so they deal with communications, and they can be configured with rules. So ISTIO is a common service mesh. Envoy is a common implementation of a service mesh proxy. Now, what does it mean to intercept communication? It means that you can have firewalls set up in the proxy, or a firewall equivalent. And so it can say that this communication is allowed or not allowed. So now let's look at a service mesh, and it has a control plane and a data plane. The action takes place in the data plane in terms of data transfer and so on. Control plane does what it says it's going to control things. So it's where the management functions are located. And the data plane is where the communication is performed. Now, a discovery service is packaged in a pod sidecar. And you can have multiple instances of discovery services, one for each pod. And it would include the addresses of containers in a particular context. So if you think about DNS, DNS is global. It may be only in your cloud, maybe a local DNS in your cloud, but it's still relatively global. It would cover all of the virtual machines in its purview. Now we're doing discovery in a very much more localized context. So let's suppose that a container wants to use a logging service. So the logging service would be in a pod, in a container. And if the two of them are in the same pod, then the discovery service would also be in that pod, and it would have the port number, in this case, of the container of the logging service. And so it is a complicated kind of activity, but what it means is that a discovery service doesn't have to know very much except about its local context. And context rules are specified in the policy section of the control plane. And so the context includes what are the instances of containers within the pod, within each pod, what containers are participating in specialized type of testing. We haven't talked about canary or A/B testing. Uh, Let me shadow one container by another so that if it fails, I have a backup. And let me manage the context rule and manage access control. So contents again lives in the control plane. So some discussion questions. How are container rules specified in Kubernetes? You can look that up. And how is a discovery container populated? How do you know which instances of what to put in a discovery container? And so that's the end of this chapter. Orchestration turns out to be reasonably complicated. And so if you look at Kubernetes and Kubernetes examples, you might get a better idea of it. This is just the surface presentation.